Hi, my name is Jan Werth, Dr. Jan Werth. I actually started as a carpenter and I made it to become an electrical engineer. I studied in Germany and then moved to the Netherlands to get my promotion, my PhD in electrical engineering. And during that time, I worked a lot with first signal processing, that's where I started from, but then it moved slowly towards machine learning and then deep learning. I did the whole thing for Philips Research in Eindhoven, and there I worked mainly with medical data. Let's say preterm infant data was mostly my topic, but any other data as well. And there I learned the core of data is data, and if you know signal processing, you can dive into machine learning and deep learning, and it's a very, very strong tool. If you understand machine learning, deep learning, you can achieve so much more than with basic classic signal processing. So interesting times we are heading up to. Yeah.
Because the whole industry is focusing a lot on AI right now.
Yeah.
Everybody's talking about AI. What's happening with AI in the embedded world?
Exactly, that's interesting. There's actually one point why I actually moved to PHYTEC, because there are many companies out there that do software, right? If you do some facial recognition or whatever, you can find hundreds of companies doing that. But the thing is, beginning 2019, around that time, the edge processing came into play. And the idea of edge processing is that you not use your cloud computers to do the calculations. You have to separate that. We can go in detail if you want to, but let's say the finished algorithm that can now run on embedded systems. And that is actually start with 2019 to become a bit more boosted, because Google and Microsoft, as they brought AI accelerator chips on the market. So it was possible before, and of course, but that spirited the idea that, hey, why not put our algorithms on the embedded hardware, and then we can use it where the data is created, and then we don't have to send a bunch of video streams, whatever, to somewhere. So there was always a question of bandwidth and also security. Yeah? If you send something, you can interfere it, right? So this kind of question came up at the beginning of 2019, and I thought, okay, this is interesting. I want to work at a company which produces such hardware so that I can bring in the understanding of AI and they bring in the understanding of embedded hardware, and we can synergize together and say like, okay, let's work on that topic together, right? I think so far it's actually great, because I can also teach our customers what AI is actually all about. There's a lot of misconceptions, what can be done, what can't be done. A lot of people talk about it, it's inflated, etc. I'm not that person. I would say it's not true. Anyhow, but the expectancies of AI sometimes are a bit off, let's say, and I like to talk to the customers and talk, okay, this is your problem, that we can solve easily with AI, this is a bit more problematic. It's not a complete self-learning system, for example. This is always an idea coming up like, oh, I just put my camera there and it learns by itself, for example. Not the case. You can create a system, you can do it, but anyhow, in many cases not so. There are a lot of things I like to clear up, I like to give workshops, and I like to enable our customers to do it themselves. So of course I could go to them and say, this is how you do it, and I'll do it for you, but I don't know, we couldn't reach too many people, and I want to boost, let's say, the German market and the idea of AI in general. So if I can tell a customer, it's actually quite simple. You're an engineer, you understand signal processing, now I teach you a bit what to do with your signals and which steps, etc. And then, let's say, the whole company, everything's evaluate to the next step, so the next level, and can do it on their own, and I'll just help them on the way and say, okay, this is the guidance. And of course, we as PHYTEC, we hope that if they now have a new tool, a really strong and powerful tool to solve a problem they couldn't solve beforehand, they need new hardware, right? And then we say, like, by the way, we also do hardware, and then we can combine that and say, you now have your algorithms, you actually want to have it run on your embedded system, so yeah, let's work together. I can help you how to put it actually on the embedded hardware.
So as far as I understand, and you mentioning 2019, all this is very new, even though it's been possible before.
Yeah, exactly.
As far as I understand, this requires new SoCs with AI areas on them, and this is kind of a new stuff.
Exactly.
But in the embedded world, a lot of times it's like a serious business, and it's sometimes the chip is not the latest.
Interesting that you say that. So first of all, just to put that aside, you don't need dedicated AI hardware. That's also a misconception. A lot of people think that you have to have it. You only need it if you really go to the milliseconds and you have a specific problem. The AI chips you can get at the moment, they're only focusing on video analysis, and they only have CNN networks, so convolutional neural networks are supported. So whenever you do anything with time series analysis, for example, it's actually not possible. So just to put that aside, so it's for a specific niche, these AI chips, and you actually don't need them. So because you can run it on CPU and GPU alone. But
it's about power consumption a little bit also.
Exactly, that you could say, because there are some chips out there, really nice. We're working now with a partner from Silicon Valley. They have a chip out, so only have like a power sync of 700 milliwatts. Wow, with a huge output on performance, only on the AI side, but anyhow. So for specific tasks, it's interesting to use that. But important thing is that you know that most problems you can solve with general embedded hardware. It's always a question, how fast do you really need to solve it? The thing is, if you think about AI, or if people think about AI, they see autonomous driving, for example. And of course, there you need a millisecond, right? That a kid is running on the street, you want to have it now, and not like, oh yeah, like 500 milliseconds later. So then you need it super fast, like very high FPS. But the thing is, let's say if you have a door opener where you want a facial recognition, does the person belong to the company? You open the door. If the person stands there for, I don't know, 500 milliseconds or 700 milliseconds to wait for the results, does that actually matter, right? And there's so many questions where the time below milliseconds doesn't matter, right? So, and then you actually, in most cases, don't need AI chips. We do have customers with like high-speed analysis of text, for example. Yeah, they need those chips. But in general, you can use classic embedded hardware. The ideas on it came up because of the accelerator chips. People suddenly saw like, wait a second, oh, now I can put my AI on the embedded hardware. It was possible beforehand, but a lot of companies never made the link, right? They thought like, okay, in their minds, AI is supercomputer, superclusters, and then this wouldn't resonate with an embedded hardware, right? Because the embedded is super low in performance. But anyhow, from beforehand, there's a lot of misconceptions there. Again, it's about training. Yes, training needs a lot of computation power, but you do that on the cloud or on your PC anyhow. But your finished model, that doesn't need any computation power, or almost none. So that is easily to transport to an embedded hardware. And the thing is, yes, for general purpose AI, I would say like facial recognition with 1 second or whatever time frame, easy. Classic embedded hardware is just sufficient. Yeah, but so I want to say, so it was possible beforehand, but now let's say it's got another boost by these AI chips. And the thing is, the interesting part is that a lot of our customers, at least we're here in Germany, they're also looking for long-term sustainability. They want to say, okay, when I have something which lasts the next 10, 15 years, because I want to put effort in, it should last. The problem is now these chips are quite new, and you don't know what's happening there, right? So any other given day, a new chip could come out, which is a bit better, for example, they're working now on chips supporting RNN, so recurrent neural networks. Haven't been done yet, so maybe quite interesting in a couple of years, but it's not possible today. And also, the companies are new. There are a lot of new chips coming on the market, really good chips, but do they survive? I don't know. Will they be bought by other companies? Can you buy this chip in a month, in a year?
10 years.
Yeah, I don't want to talk about 10 years, right? Here, right? Yeah, but I talk about in a year, right? So the company we are working with at the moment, it's a I don't know, startup, not anymore, but kind of startup. They have huge partners, so they make a lot of money. I think they're sustainable. But on the other hand, if Google say, you know what, you have the GPU, we like your company, we just buy it, and then all our contracts we have them might be void. So that is an interesting field. So it's people or customers should get used to the fact that, yeah, maybe you have an AI chip, but it will be not there in the next 10 years, right?
So it's good to work on some open source kind of like software that's easily portable to another chip if you need.
Exactly. So in most cases how it's done, you create your model, you use TensorFlow or whatever, you create your model, and then you have an SDK or an MDK, like a model transversion kit or something, and that's supported mostly by the companies. So you have your base model, and then you convert it to that specific chip, and then you have to integrate it. So actually, you're right. Even if your chip, let's say, would fail, it wouldn't make the 10-year mark. Probably you could at some point exchange chips quite easily. Yeah, that's
so
right.
One of the established ones that everybody can rely is going to be there forever, for a long time,
Yeah.
is the Touch NXP, right?
Yeah, interestingly,
They are
NXP.
probably fine. I mean, for example, here, you have something happening with the IMX 8M. That's
Exactly.
going to be around for 10 years.
That's
15.
right. But this IMX 8M doesn't have any AI accelerator. I heard rumors there will be a new chip out there. Probably when you post the video, it will be already done. That they have a new board with AI acceleration on there. So that should be fine. So with them, you should go quite for the next 10 years because NXP in general is looking for long-term sustainability.
It might be compatible with this one.
Yes,
in a
I
big
heard
way.
if it's even a bit faster. I heard. So I'm looking really forward to that one.
Nice.
But exactly. So, but of course, there's also Google and Nvidia and the big players. Mostly they will stay in the game because there's a lot of money to be made, and let's say smaller companies we just have to wait.
Which is the other solutions you're working with?
At the moment,
Some examples.
You know, we're working at the moment with Falcon. So Falcon is one of a Silicon Valley company, smaller one, but they have a huge customers, let's say. So they're going for mobile market mainly. And the good part about the Falcon is, again, super low power consumption. The problem with all the other chips is the Nvidia Jetson, for example, or the Google TPU or so, they have a huge power consumption, right? So they're getting really hot, so you mostly need active cooling or something like that. And for many of our customers, they look like a low power, that's actually the low power solution, right? So Nvidia and the Google TPUs are really interesting to have a first check, like a proof of concept, and to see like, okay, now I have an ARM system, I just try if my algorithms work there, I make them ready for ARM, I see how good the solution works, can I solve my problems? And a lot of customers then come to us and say, okay, now we need something more, let's say, not desktop-wise, more professional, more industrial-like, and also it's a support, of course, right? So the difference between, let's say, PHYTEC and Nvidia is that you can call us and say, you know what, I have a specific sensor, and I can't get it into my BSP, can you help me? So yeah, of course, we can do that. Good luck calling Nvidia and saying, hi, I don't know, Heinz Müller Elektrotechnik, I need some help. And say, yeah, good luck, call our support or something. So there are the differences. So many people start off with something like Nvidia or Google Coral or something, but they come to us because, again, most of them notice you don't need that super high performance, right, for your solution, right? Nvidia is very good as a high performance, but on the other hand, as I said, a lot of power consumption. So if you want to drain that, lose that power consumption, you go to a different system, right? And then you notice like, wait a second, my solution works perfectly on an IMX 8 from NXP, right?
Quad-core ARM. It's a quad-core ARM Cortex A53. Do you also work with the Nvidia solutions?
I tried it. I of course tried it, but I definitely don't work with them. So for all our customers of customer projects, I will always work with something we have, because mostly also they want to have a specific solution for a specific problem, right? So they don't need a one-fits-all. They need like, okay, we have that device and that has to be managed in a specific way, and we need facial recognition here, and it has to have that sensor. So then, sorry. The Nvidia would be too general purpose, right? So we can say, yeah, okay, of course, we break it down to exactly what you need, and we're happy to implement TensorFlow Lite, whatever you need, of the libraries onto the BSP. And so far, all the customers are quite happy. Yeah.
All right. So what's the demo here?
Yeah, interesting. So we have two demos. This one is like hand recognition. Can you see it still? It's just it's very simple. It's two hand gestures, hand open, close, and that is actually made with Microsoft Azure or Azure. I don't know actually how to pronounce it.
Any hand is good.
Exactly. Yeah, any hand should be good. I think you should. Yeah, you have to put it in this video.
Camera.
Yeah. No, yeah, you have to. It's a specific like in this way or hand close. Oh, only 80% can get better.
Yeah.
And 100% perfect. And open hand gesture. Of course. And so the idea is that we show here with Azure, you don't have to have any knowledge about AI. So you can just upload your data and click and play and just download the device again on your device. That is for customers showing like this is very simple. You can train it on different hand gestures or whatever else, but of course you can also do it yourself, right? this for the people who really just start with AI, just a glimpse of that. And then of course we have another demo where you have, in this case, this is a very simple facial recognition. And first of all, I have to go closer. I get a facial recognition, and if you then press a button, it determines your facial embeddings. And from that I have like I think 10,000 pictures of celebrities, and it finds out which celebrity you are based on the Euclidean distance between your face and the face of the celebrity. And that is completely from scratch, so we can show it's also native on there. While on the first one, we use Azure and also the Azure IoT Edge SDK, etc. So it's everything built in. While here it's just native incorporated into the BSP. And that's like the two ways. So we can show like, hey, we can help you building it from scratch, and we also can help you just have a first startup with Azure or something, right? And also the second part is interesting. So you notice, for example, just so information for you guys, you notice that the calculation of the celebrity face was actually relatively slow, to be honest, right? What happened is that the facial recognition is very fast. It takes like 0.2 seconds. The creation of embeddings is also very fast. It also takes around 0.2 seconds. So in general, that would be taking 0.4 seconds. The thing is, we have an NumPy array, for so people who know that, right? You have a NumPy array, and it's just calculating the Euclidean distance between your face and all the embeddings we have there. So and that takes time. And interestingly, if you maybe noticed, that has nothing to do with AI. This is general programming, right? So that was a bit fastly done before the fair here. But so I would now have to put my mind into it, how to boost the general algorithm. So the facial recognition and the embedding creations, which is deep learning, that is super fast even on such a embedded hardware. But the problem is it's just a classic crawling of a NumPy array, right? And then there are also some solutions how to do that better. So just for you at home to know that, the problem is not always AI, right? The problem is your program in general. And AI, artificial intelligence, doesn't always mean only deep learning, right? It means the whole thing, from somewhere to get the data, transforming your data, get something with your AI model ready, but then also using that data for something. And the whole thing, that can become quite bulky, right? It depends on your problem. And then you have to see, does it still run fast enough on my embedded system, right? So,
how big is it going to be, the AI stuff? Is there a way to do you think it's going to be revolutionary for the whole embedded world?
Yes, I think so. I don't know. Yes, for sure. The thing is, especially with the topic of AI, I would say never things like never, because it's going very fast and it's really difficult to see which direction. A lot of people are afraid to say like it's all a hype, because back on the history, right, back in the 70s and the 80s, we had already like this AI winters, and people are a bit afraid like, oh, you're putting too much expectancy into the topic again and you'll lose again. But seeing what's happening right now, I don't think this will happen. I think it's actually great, and it will go forward very fast. Yes, and of course, it revolutionizes also the embedded industry. I mean, we saw that already, right? From the last couple of years, I think actually Nvidia, Intel started 2014 with videos, if I'm correct. Correct me if I'm wrong. So it started already a bit back, but now we have a boost. A lot of companies creating this AI chip. So suddenly, there's a complete new topic on the market, and let's see where that goes. And yeah, in general, with the topic of AI. I think it's exponential growth, also like with inventions, etc., and where we're going, especially because it's open source. Everybody can participate, and everybody has a bit of knowledge of coding, can dive into the topic. By creating such a system and building such an embedded hardware is a bit more difficult than just writing a Python code, I would say, right? And so, let's say everybody can do the Python code. So we have a huge mass of people working on AI, privately and in business, and that pushes it very fastly forward. And we humans are always thinking in linear terms, right? So, okay, the last 5 years, that happened, so I can estimate what happens the next 5 years. But with AI, I would say this is more or less an exponential thing, so it's really hard to say how long what will take. I remember talks with people 2 years back saying autonomous cars will never come. And sorry, look into Silicon Valley, autonomous driving is already there, right? And that was in a span of 2 years. So it's really difficult to estimate anything at the moment. So, but I think anything is possible. So I'm really looking forward to that.
In terms of priorities for society in general to like be a greener, let's say, is it good to have edge AI compared to more and more cloud AI in terms of saving
That's a good question.
Energy consumption, or that might be another way to make it a big priority, because if you get a lot of small ARM chips doing a lot of smart stuff in the edge, it can really solve a lot of problems.
That sounds really nice. To be honest, I don't believe so, because I think it will only generate more devices. I think the people will not step back from the cloud, because when a lot of applications, everything goes on the internet, is in the cloud, so they will put their AI algorithms in the cloud, which needs a bit more calculation power. Especially also the training also for the embedded devices will be done in the cloud, so or on your desktop PC, but that will take a lot of energy consumption again. But in general, we just will produce more, let's call it smart algorithms, which in general will need more power consumption. So I hope it would be interesting if that would take that direction, but honestly, I think we just have more solutions which will suddenly needs more embedded things, right? Which maybe have been done before with very low power computers, and suddenly needs a bit more high power computers, and that will in general create more power consumption. I hope I'm wrong on this point, to be honest. Yeah.
But edge AI means more devices, because it's going to be more demand for more stuff out there, more things everywhere.
Yeah. And to be honest, it's also the case with embedded things. Again, back to the idea of solution, right? So I have a problem. I say facial recognition and so on. So I could take a really low power, an IMX6 or something to get my solution done. But a lot of people say, no, what there? Oh, there's an IMX8 as well. Oh, it's a bit more powerful. You know what? I will be on the safe side. It's AI, but maybe I'm not too familiar with the topic, so I'd rather go with a stronger one. I don't know. I don't know if that's happening constantly, but anyhow, that would be something I guess we have in mind. And then that again will push the power consumption in general. So I hope that people will realize after a while that you take the CPU you need for the problem and don't overpower. I think in the industry or so, people go this way because it's always about, to be honest, cost and efficiency, right? So say like, okay, the slow one is a bit cheaper. Can I solve that with a cheaper device? Yes, I can. So we'll go this direction. But in general, also privately, or just, solving problems in general, go for the solution which just fits and not overpower. That would be one thing to save a bit on the power consumption. Yeah.
Do you have 2 or 3 or 4 examples of kind of like projects that you might be excited about working with customers to implement?
Yeah.
And what PHYTEC is perfect for?
Interesting. Oh yeah, there's. I think you have to be careful.
Maybe there's some NDA.
Yeah, there's several NDAs, right? To be honest.
There's a bunch of them?
Yes, exactly. So it's interesting. So we have a range, let's say, I can about more broadly. I have a range of customers, and all of them are interesting because they start from a different level. So we have very, let's say, small companies who have no clue about AI. I love working with them because I give workshops, I go to them, and I have, like, for example, one general purpose workshop where I display what is AI in general, but also going in detail, how would you program that, what's a layer, what are the parameters, etc., overfitting, how to solve that. So it's really from to, and I noticed during and also after those workshops, those people say, oh wow, this is great, now I'm really elevated to the next level and I actually can start working on my own. This is one type of customer, I'm looking forward to work with them. The other ones are, okay, we know AI, we have our own maybe even department or at least a few people working with that, so I don't have to explain them AI. And then it's more about, okay, how can we transfer our solution on the embedded hardware device? And that's also interesting to look, okay, the problem, okay, what solution do you have? How do we get it on the embedded hardware? That's also interesting to see. And what hardware do we take? And then, of course, the last ones, which is like, we know all, we just want to buy. And that's also nice because this is quick and easy. Yeah.
And also, how easy or how hard is it for an embedded software developer, embedded hardware developer to get into this field?
It's difficult. Some people would say difficult. I would say medium, because they are bright people, they're smart people. They mostly know how to program, especially if you know how to program Python. Yes, it should be easy. I mean, it's easy for me to say because I come from a signal processing background. That was my study. So my drive into AI was a bit more easy because actually 90% of your work, if you go on AI, is actually signal processing. Until you have your data nice and clean, and then you start with the nice part, creating a model, right? And that is actually not, let's say, too difficult. The whole thing can become difficult if you have no clue about signal processing, etc. What is good, like identifying a problem, identifying the solution for the problem, going that way. This is actually what you have to think about. Programming the deep learning model itself, you will find hundreds of tutorials, and if you're already an embedded hardware programmer, you're a smart guy, you'll figure it out. So that's not a problem. The problem is more the whole thing. You have the problem and find the solution and all steps on the way. And there are many steps which can become difficult, right? How to actually collect your data, how to clean your data, get the right, how to synchronize your data. People, think about that, how to synchronize it. This is a step. Okay, tip from me now, from the fair. If you're thinking about AI and you have multiple sensors, or you have a camera and maybe sound or camera or accelerometer or something, before you start anything, think about how you synchronize your signals. If you have done that, you save yourself a lot of work in the long run. So yeah, do your signal processing good and you will have fun doing the AI part.
How do you process the signals good?
That is, how do you process signal? This is a very broad question. It depends a bit on what you, what the problem is, of course. But let's say, yeah, if you have a solution we want to solve with video analysis, for example, right? So, how many frames per second do I need? Which resolution do I need? Do I need it in color or grayscale? Is the information in detail? Then I need a higher resolution. Is the detail not? Is it just like person recognition or something? You can go really small with your data. How about not a number values? You have to kick them out. Again, synchronizing data, normalizing your data. All this kind of stuff. There's multiple small steps you have to go through. But the difficult parts are mostly getting rid of noise and synchronizing your data. That are actually huge problems. And then, of course, don't forget that annotation. So, for supervised learning, which is most cases you will go to the direction of supervised learning, you need annotations. Meaning, you have to tell your computer, this is a picture of an apple, this is of a banana. Banana and apple, that might be actually easy at this point, but if you go for image segmentation, for example, so that you actually have to do every image by itself and segment it, this will take a lot of time and effort, and you have to do it properly. The thing is, if you have a general problem, that is easy, because you probably already have a data set online, which is more or less the same your problem is. But as soon as you go special, let's say I work with preterm infants, right? My PhD was on preterm infant sleep analysis. The problem is there's no data set on preterm infant sleep analysis just there out there, which is annotated for sleep states. You will not find it. So you will have to get professionals in there. You have to build tools for the professionals that they annotate it. You have to get interoperability. You have to synchronize all the annotations with your data, etc., etc. That will be the problems. So again, as you see, per question there will be different problems. But it's always have to keep in mind. Let's say, good to have in mind, especially for people who are in management positions. If you say like, oh wow, we want to do AI now, give your employees a chance to do the pre-processing properly. So an AI project would be 90% pre-processing your data and collecting data and annotation, etc., etc., and then 10% creating your model and get your inference model, right? So in this scale, so even after 6 months or so, if you're like, oh, where's my model, and they still tell you, oh, we're still processing data, etc., don't push them too much, let's say, and don't be afraid that the next part will also take 6 months. No, the last part will be then much faster. So just be patient.
Are there like, what do you call them, libraries of data that's already annotated, provided by companies like Google or something like that?
Exactly. Actually, it's mostly all open source, and thanks to the community actually for that. There's the ImageNet, there's Coco dataset, there's MNIST dataset, hundreds of datasets. Actually, if you Google open source datasets, you will find hundreds of them for really specific problems. It's great, and to say, there's people who dedicated their time to do that for an open source community. So I'm really grateful for that. And actually interesting, what's really interesting is that GitHub is working just on a project at the moment that you can upload your data, but it will be anonymized on the way up, and so you don't lose your company secrets. So if you take from the community, I hope you also will give back something to the community in form of tutorials, how you did it, algorithms, maybe your data. That would be actually really great. I understand that not every company can just give their data away, but if you can give something back, that will be actually awesome. Yeah, and because we have to think, AI wouldn't be possible without open source. TensorFlow is open source, Caffe, whatever, all the programs, Python in general, everything's open source. So you use that. You have to say, we built on a lot of work from private people, a lot of energy from private people, so try to give something back. Yeah.
Are the winners in AI going to be open source or proprietary?
Oh yeah, it's open source, yeah, because everything is open source. Because the thing is,
it's not like a big company like Google is going to own the whole AI future.
No, the thing is, because how do they earn money, for example? Microsoft was very clear about that. They say, program your solution however you want to. We don't care, as long as you come to our servers and calculate your models on our servers and pay money for the calculation power, right? So that's how the companies now make money. So they rent you their servers and you pay them for their computation power. So actually it's for them it would be really good if it's more open source, if you can do more and more and more, because the more solutions that can be solved with AI, the more computation power is needed, and then they can sell you that. So actually the big companies are interested that it stays open source. There are some companies, I don't want to name any names because I don't know, might have bad blood or something, but they like classic software development companies which were closed source, very good, and then they start now also with AI because they started panicking a bit, noticing like, oh wait a second, we're losing a bit on the libraries on AI. I have no experience with that, so I don't want to say anything false, but I can imagine that there might be always a step behind, because everything you find which is really just up to date is always open source, right? Okay, of course there will be Audi, BMW, Mercedes, Tesla or so, which working on their autonomous driving software. That is of course closed source, right? But I mean in general, the libraries in general, how you would do something like the latest facial recognition model or something, that is always open source.
You were mentioning about an important part of synchronizing the signals or the data. How do you do that in a good way? What's the strategy for synchronizing perfectly?
Yeah, the thing
is there a simple way to do that, or
no,
not simple, but standard way to do that?
And also, unfortunately, I wouldn't say so. The thing is, of course, people always say clock, right? So you would have every signal which you produce should have an internal clock, but the idea is to get your mind into your problem beforehand and think beforehand, how will I synchronize my data? Because if you once recorded your data, then it becomes really difficult to synchronize. So either you make sure that your clocks are actually synchronized beforehand and say like, okay, perfect, I'm sure that my clocks on all signals are synchronized to each other, then it's fine, you can just have a timestamp, wonderful. If that is not the case, maybe I can give you an example from the preterm infant case, you can understand it better. So we had video analysis, but we also had ECG and EOG and a lot of signals, and we had to synchronize them. And they thought like, oh, we are super clever. We just plug, because the question was like how to synchronize the video with the rest, which the rest could be getting into one box something and then be recorded simultaneously, but the video would be separate, for example. And then, okay, how to connect the video to the data. And they said, okay, we just deplug a plug and put it back in, and then we have a noise peak. And then we just find the noise peak in all our signals, because they were also a bit time shifted in the box, and then we can synchronize. Very nice idea. The problem was the signals themselves are so noisy that it was very, very difficult to find the artificial noise peak, for example. And these are the things to think about, okay? How do I create something where I can identify that is the same time point in my signal? And the problem is, again, this is not one-fits-all solution, because there might be, maybe your problem is very simple, and you don't have to do it. Maybe you only need a video stream of your screws and you want to determine if the screw is good or not. You don't need to synchronize anything. You only have to synchronize annotation to your data, but that you can do as a tool, right? You create a tool where you annotate that should not be a problem. But as soon as you have multiple sensors, then the problem arises, and then you have to think about how to synchronize before you actually start recording, right? To do some test runs, try runs. I mean, I come from the medical part, where it's very difficult to just set up a new trial, to just create new data. It's just impossible. So you have to think a lot beforehand, but that saves you a lot later. And also with parts where you just can create no data, it's always good to have your solutions beforehand and then start recording, because also in the nature of the humans, we don't like to go back. So if I want to create my data, I'm already starting with creating my deep learning stuff, and then I notice, oh, my data is not synchronized. Then I don't like to go back, because in my mind I just make a check mark on the, I did my data, fine, I can now start with the AI. I already told my boss I'm doing the model now, I'll give you an update in a month or something. And then you have to go back to your data synchronization, and in a month you say, boss, sorry, I'm back in data synchronization. That's never good, right? So start in the front, start with thinking about your problem, think about the solution beforehand, take your time. They want to say, take your time with that. Tell your boss, it will take time. It will take the most time, and don't worry, the AI part later, the deep learning part later will be a bit faster. And stand your ground on that, and that should be the solution. That you take your time to think about the problems properly. Yeah.
So without trying to get any secrets or NDAs or anything, but let's say PHYTEC was developing a solution with a customer that has to do with sleep tracking or something like that. With that, what would be the perfect implementation? What's a great idea to use AI and sleep tracking or something like this?
That would be great, actually. This is my favorite topic, right? Treatment for sleep. That would be great. It's very difficult, unfortunately, to actually solve that problem. Please continue to work on that. But anything, I would say, anything which should be separated from your cloud, let's say. You don't want to have a device which you always have to plug in and have an Ethernet connection for something. And you don't have the means to send a data stream via Wi-Fi or something, right? That is always the idea for edge processing. And also, of course, security, right? Whatever you send can be intercepted. If you only do it on the edge, somebody has to go to your device and exchange an SD card or something, or hamper with your device itself. So as long as you don't send anything, then you're fine, right? If you're afraid of losing your company's data secret or something like that, do it on the edge. It's really difficult to intercept here. So handheld devices, everything which is running on batteries, for example, that will be, of course, edge solution. Everything which is a difficult location, right? A deep down tunnel, underground mining, for example. How would you send data to anywhere, right? So then it would be maybe a solution of a kind of edge fog solution, where you have like a mainframe somewhere in the underground in the mine, and you send some data to the mainframe. That would be possible, but it's even better if you just have the device on your operational devices, your edge device on the operational device, and you say, oh, you're mining here. We want to identify what you're mining, and I found just coal. Just give a signal to the operator, we found coal. Perfect. You don't need any cloud. You don't need anything to send to it. It's like where you need it, you get the information.
So perhaps it could be like a sensor on the bed that's IMX8M, and that can sense there's two different people sleeping in a bed, maybe, and identifying who's who, and also how long you sleep. It's really important to sleep to recover. Like there's a few talks here at this conference about the coronavirus. I heard that if people sleep good, it's the best protection for any kind of flu or whatever.
Yeah, it is actually.
It's just sleeping, because the body is repairing itself at night. So if you can do that on the edge and then only talk with the cloud, what's relevant.
Yeah, exactly.
You could maybe develop something there.
The thing is, that would be actually, it's quite interesting. Sleep in general, right? Your immune system is actually regenerating during good night's sleep. So if you don't sleep, actually your immune system will be overloaded, and then you're really prone to diseases, right? So sleep tight, sleep good. But this is actually a good point. Recording, for example, somebody in the bedroom. Nobody wants to have a video stream of themselves in the bedroom somewhere at Amazon or Microsoft or so. So that is also edge a solution, right? So yes, maybe to your private cloud you can send information, you have that in a sleep pattern, but no video stream is sent anywhere. So you can do your video streaming on premise, just analyze the people, no videos going anywhere, because only the solutions may be sent to a server side. And also, especially in Germany, with our ruling here, DSGVO and so on, then it's interesting to not create people and to not recognize, let's say to not identify people, right? So that to separate that. from each other. And yeah, about the sleeping pattern, that would be generally interesting to see right, sleeping patterns of people. And also I mean, I'm always dreaming of the robot at home, right, whose combination of several AI, identifying if I'm sick, seeing what's in the fridge and going to the shop and buying stuff for me. That I'm looking really forward to. Please continue working on that. But also there, like this is far, maybe not that far out, but it should be far out, right?
2021.
Yes, exactly, right. 2021. That should be done. But the idea is also here. I actually wouldn't like that the robot would have all the information and send that to Microsoft or Google, the robot company owner, right? And then I was like, you know, they know everything about, they do already, but they know video stream, whatever, they're all about me. So that could be actually hampering also for robot industry hampering selling point, right? If you say, actually, I don't want to have a robot in my bedroom and sending all the information to everywhere. So if you then go edge and say, no, nothing is said anywhere because only maybe the models are updated if the robot is once in the shop or something, right? So actually, no data is sent anywhere. Just the robot has the model in itself. It operates on itself. It can have a solution. It gets a solution and operates on that solution. But no data is leaving the robot. That would be actually, I think that's a key point for that direction, robots in our homes. Because I know, at least in Germany, a lot of people are kind of afraid I don't find the right word, but Alexa, right? I know a lot of people don't like Alexa. They maybe bought it first, but then they notice like, wait a second, it's listening really on anything I think here, and they get rid of it, right? So that is happening, and the acceptance, at least in Europe, I know Asia is a bit different, but the acceptance of a robot here in Europe is really dependent on where is my data sent, where's my data stored. So they know it already, probably who's working on that, you know already, but it's a solution for an autonomous robot in your home. But yeah, so that might be also the future actually for embedded systems. To say everybody now don't have a car, everybody has a robot, so we'll have a lot of embedded hardware now to sell.
The robot could be like helping people live a more healthier lifestyle and advising on sleep, advising on food, advising on noise, any kind of thing that,
yes,
and just saying, hey, now it's a good time to work, now it's a good time to relax.
Exactly.
And just be on the side there, like a coach.
Yeah. Hey, taking over my programming because I can do it better probably at some point. No, but you're right, exactly. So anything you can imagine now with a small app, for example, right? Yeah, my food intake, how many calories did I eat today because I want to get slimmer and fitter, for something like that. Yeah, a robot can easily, can take over that, because what would be a robot? A robot would be, let's say, a computer system with a vision system which can walk and has hands, maybe can touch things, right? So it's not that difficult, not that much different from a smartphone. Yeah, it looks like different, but actually computation, etc., is more or less the same. It would be apps probably running in the robot saying, the health app, okay, I look at you, I identify you and tell you, hey, you look sick, right? Or something like that. I think that the problem only there would be like touching things and etc. That might be like the mechanical problems more. But I think they're working. Boston Dynamics is working on that. So I think actually we will see something like that rather soon than later. So.